Welcome to part 4 of Beginning Your Game, and I'm your host, Michael Allar. Now, in the last part of this series, part 3 of Beginning Your Game, I went over some of the changes I did to uh, pretty much revamp my tutorial series to go side by side with a game project I'm working on called The Hunt. Now, in that, we created a UDK game class, which is just a generic game info class that we can use. And we created a HT player controller and an HT pawn, so we can have some custom pawn and player controller stuff in there. But in part 3, in the written version, I've also included a second game class, which is just called the Hunt game, which we'll be using to put in gameplay code later for any map with an HT prefix. You don't have to add that. You can still base your code off the original game info class, but it's good to have a generic game info class for things like front end menus and stuff like that. So, and it's easier to, with that generic class, you can add in multiple game modes by just deriving from that. But now we're at a point where we have everything set up. We just need to add two more classes, I believe, two more, in order to create some custom weapons and things like that. Now, because of my project's need to try to stay away from as much UT code as possible, we are going, no, I was adding some weapons earlier, and all my weapons were derived from UT weapon, but I finally got around to deriving from basically the UDK weapon class, and ran into lots of problems. In fact, this tutorial series is going to be broken into many parts just to go over how I've figured out or step by step of my process of how to get a weapon working. And once you do it once, you'll know all the little things you have to adjust for in the future, and your weapon creation process will be much faster. But bear with me, it's going to be quite a long process just to get our first weapon in there, because we have to change a few classes around in order to get our stuff working, not based on UT code. Because there's a lot of UT code that did a lot for us, so we're going to have to be rebuilding a lot of basic features like ammo and stuff like that. So, if you look at your class browser in Uncodex right now, you'll see that under inventory, you won't have HT inventory, but you'll see that under UT inventory, you'll have 3 inventory objects. Now, the current inventory manager, also right below inventory, is UT inventory manager. And this only deals with UT weapons and UT inventory classes, and not any other class. It doesn't use the base weapon class or the base inventory class. It uses UT weapon classes and UT inventory classes. Now, we have to create our own manager and our own inventory item in order to not do that, because we can't simply derive and just replace everything in here, because there's just some things we can't do by deriving. Like, we can't go in and, we can actually do a lot of stuff through driving, but it'd just be so much copy paste of redundant code just to change one variable. It's easier for us to create our new inventory class, and that way we can start from scratch and give ourselves more control over every aspect. So, what I'm going to be doing here is I'm just creating a shell inventory manager that has just some basic functions taken out of UT inventory manager, but tweaked and fitted in order to fit our project. See, as you can see, the UT inventory manager is around 738 lines of code, but it also has lots of features. While our inventory manager that we'll be creating right now is only 133 lines of code, and it doesn't really do much at all. In fact, it almost does nothing. Now, alright, so, yeah, and we have to do this so that we can create our own HT weapon class, or whatever prefix we're using, because we're not going to be, for our project, we're not basing our weapon code off UT weapon anymore. We're basing it off our own class, so we have to use the higher up UDK weapon, which is only available in the February build. They added that. If you don't have that, you could base off game weapon, but I recommend getting the latest version of UDK and installing it so you can follow along better. Now, so the two, actually three classes my guy will be adding are HT Inventory Manager, HT Weapon, and HT Inventory. But right now, HT Inventory has nothing in it because there's really I haven't coded any items for Hunt yet, and neither have you. So I'm not sure what to expect there yet. And as I stated before in the very, very beginning, it's just I'm making these as I go, so I'm learning things as I make these. So some things may be wrong, but I can, at the end of every tutorial, you'll have something working if you follow the steps. Because what I do is I create it, and if it works, I go back and make a tutorial on how I did it. But there are some things I'm going to have to go back and fix later on, and that's just a whole part of the process here of learning UDK and learning Unreal Script that I'm going through. So, yeah. Now, creating the inventory manager, what I initially did was I took UT Inventory Manager, I hit Select All, copy paste into a new subclass, HT Inventory Manager. And then I went back and I basically deleted every UT specific function I could find, or not specific, but any class that was in UT Inventory Manager, that was specific to UT Inventory Manager, that wasn't an Inventory Manager, such as Adjust Weapon. Adjust Weapon basically selects a weapon that's like the next weapon or the next two weapons next in the list that from your current weapon. Explain that's a little weird, but like say if you have three weapons, you're in weapon 1, you can do Adjust Weapon 2, and it will get the third weapon because it's the 2 more weapons ahead of your current weapon. And right now that's all using UT weapon stuff, and so we could easily replace that as HT weapon, but I found it easier just to rip it out, and if we need that functionality later, we can go back and re-add it, because it's better to start with a clean working slate and add stuff later than to have a bunch of code that's all broken and going back and fixing each function over and over again until it works. So I'd rather just have no functionality and then build up instead of having a bunch of broken functionality and tearing it down as I go. So by tearing it down to begin with, you kind of have an easier thing to start with. But this code here allows really easy previous weapon and next weapon logic to happen, but I didn't include those either. So, yeah. And there's also some things like all ammo, which takes your weapon and increases its ammo to the max. But then there are some important things here, like set current weapon. These here do exist in the inventory manager. Set current weapon right here. But the main difference here is that it will, if you run this, it's going to automatically set the weapon on the client no matter what. But in UT inventory, you'll see that what they did was they made it, they basically did the same thing, but they have a pending weapon. That way it stores, like while it's switching weapon, there's a variable somewhere that stores what variable or what weapon you're switching to. And that variable is also in the inventory manager, so I decided to leave that. But then there are things like, where's a good example? Here, like create inventory. And create inventory exists in inventory manager. But what it does is it adds an inventory item to a player's inventory every time the function's called. However, what UT inventory does is that it checks to see if we are currently have the authority role for actor before it creates an inventory. Now what this means here, this authority role means, is that Well, every actor in Unreal has two roles. It has a role variable and a remote role variable. The role variable is pretty much tells you if it's either the actor that it is either a local copy of the actor or it actually owns the actor and controls it and has power to manipulate it. Now, for things like inventory, you want that server sided, and every actor on the server side has the authority role. But you don't want your players to have control over their inventory client side, because then that would allow them to add inventory on their own free will through outside means, like basically cheat their own inventory, and that way, and it'd be harder to validate with the server and stuff. I mean, you could replicate it, but then the inventory management would be all client side, and that could be very bad. By making it server side, only the server has access to manipulating players' inventories. And we do that by checking to see if we have control over the actor. And if we do, that means we are in a position where only we can change that actor. And that can be the dedicated server running this function, or it can be the host of a listen server running this function, or it can be a single player game, because in all those cases the host has full control and the client should not. And whereas in a single player game, the host is the client, so it doesn't really matter. I mean, if they're going to cheat in a single player game, it's not going to be that big of a deal. And they have full control anyway, because it'd be pointless to host a single player game on a remote server for somebody unless it was like a very stats heavy, like MMO type of game, but that's besides the point. Now, this process retry switch is a bunch of logic that handles switching weapon with a timer and things like that. That isn't in Inventory Manager. I decided to take all this out, but you'll see things like add inventory. It's using UT weapon. What I did is I went back and I took out all the UT weapon references and made them HT weapon, and I also took out all this ammo storage code, because at the top of this class you'll see that we have somewhere here we have an ammo storage variable, and that basically is a variable that holds ammo that allows you to hold ammo without having you actually hold the weapon the ammo corresponds to. Now, I figured if we need that functionality, we can add it in ourselves and do it our own way instead of doing it in Epic's way. So I took out everything that references ammo storage. So it's just this here, and I also took out infinite ammo. Just things like that we can code in later. But what I did leave in is I left in these two lines here. I left in previous weapon, because that sounds like a good functionality I want to include. Store the previous weapon we had. Seems like a nice idea. And then pending switching weapon, because some of the code relies on this, but I made this into a HT weapon. So I hope I did. Yeah, I did. Alright. Now, this whole replication thing, because it's only adding B infinite ammo to a replication. Replication is basically a way of having variables on the server and the client synchronized so that they're always the same value. Because I took out infinite ammo, I took out the entire code block. And another thing I did is for get weapon list. There's a lot of optional variables and things here, and this does not exist in Inventory Manager. So what I did is I basically stripped it down, and it's doing a get weapon list sorted by their inventory weight. Every UT weapon has a weight amount that, like, the Enforcer is like the least weight, I believe, and the Rocket Launcher and stuff like that has a higher weight because it's a better gun. Something like that. So what it does is it builds a list of weapons and sorted by their weight. Now, because we don't have weapon groups or weights or things like that, I took out the group filter and I took out B filter. And I don't even know what B filter does, but Yeah, and I took out the for loop, and what I do is I just, for each inventory actor, I just add it to the weapons list that we pass in. And there's a new type of parameter here called, or there'll be a keyword called out. What out does is whatever you pass into the function, if you manipulate that variable, whatever variable that was passed in also gets manipulated. It's kind of like you can pass in a variable to get manipulated in the function without returning it and assigning it, stuff like that. The optional just means you can skip that by just like comma, comma, and completely skipping that. But I took out these. I did leave a no empty though, be no empty, because there is a, in this if statement here, you can put in true in there, and it will only return weapons in the list that have ammo. I think that'd be kind of useful. I mean, why take that out if it's already there? But if you put that in false, then it's always going to return a weapon, even if it has no ammo in the list. No ammo, so it'll get added to the list anyway. And yeah, things like switch weapon. This switch weapons to this switches to a weapon group, and we haven't implemented weapon groups or anything like that. So I took out this entire function. So the end result is 133 lines of code, and it works as far as I can tell. So, one thing I did copy straight out was has inventory of class. I think that'd be useful to search the inventory to see if they have an instance of an inventory class. But yeah. So, and I did take the change weapon class or change weapon event out of HT or out of UT inventory manager as well, because that way this event or this function gets called every time we change a weapon, or every time a weapon is fully deactivated, something like that. And that just stores the previous weapon in our variable at the top, and then it runs the base code for change weapon. And that allows us to do a switch to previous weapon, which basically tells the previous weapon inventory to go, hey, I want to be set. But that's some logic we'll get into later. So, yeah, I'll be posting this code on the written section, but I won't be writing up an explanation for each line of code, because this video tutorial, I'll just be walking through it. And, well, let's get started on that. Like, for this main get weapon list function, what it does is it runs an inventory actors function in the base class inventory manager, which basically acts as an iterator, so it just returns all the inventory actors in the inventory. And if the weapon has ammo, or if no empty is false, which translates to true, this is not, basically depending on our no empty flag, if the weapon meets that condition, if it has ammo or not, it just inserts our weapon into the first thing in the list, because the other code was using insert, so I figured just insert it in here. And well, that inserts a blank spot, and then it assigns that to the weapon in our iterator. That's how we do it. Now there is a way to just append weapons, but I just wanted to keep the code similar. That way you can see kind of the process of how I did it. Now we'll be revamping this code a lot in future parts. This is just the base slate to get things running. And we also have some things like these that are just taken right out of the UT inventory. An accessor for a server to begin weapon switching to client. I thought that was pretty important, so I left it in there. And yeah, these create add inventories, all they're doing is they're basically doing the same thing base class is doing, except it's checking to see if you have ownership, because the hunt is going to be a multiplayer game, and I don't want client-side operations to manipulate inventory, and only the server should have control. And that's just taken out of UT inventory manager as well. Now discard inventory does the same thing, except it also discards vehicle driver inventory as well. That's also taken out of UT Inventory Manager. So figured it might be useful, even though I don't plan on having any vehicles in there. Remove from inventory, same thing. And it's doing some weird thing here. This should actually not be there. Alright, so I'll be taking out this variable here. Yeah. I'm going to save that. No, I'm only using previous weapon. About that. So, and then has inventory of class. That just checks. Oh, there's an inventory chain, which I guess is just like a list of all the, or a chain of all the inventory classes you have in your inventory, and it searches for or loops through each class, and if it matches the class that you passed in, it will basically return it, and if it does, it has an instance of that class. If not, it doesn't. So, and we've already went over change weapon and switched. Now, these default properties is also taken out of UT Inventory Manager, but it's also really simple. B must hold weapon equal true. That means you can't switch your weapon to none. Like, you always have to be holding a weapon. And pending fire, I don't know what that really does yet, but it's basically what I believe is that it just stores, or it tells the weapon or the manager that the weapon's not being fired right now, so don't do any of the fire logic and things like that. So that's the HT Inventory Manager class, and I'll be posting this in the written section, but I won't be doing a line by line like I did before, because you should start be getting to the point where you're able to read this and understand more of it. And a good reference to read, like if you find a keyword or something you don't know, always pull up not Pandora, always pull up, just search UDN Unreal Script, and you'll get the not the stage, but you'll get the Unreal Script language reference, and this is an excellent document with lots of good documentation. And basically you can just Control F and say you didn't know what simulated did. You can search simulated, and there's the keyword, and it tells you exactly what the keyword does. And it basically what simulated does is it tells a function that it can run on an actor that doesn't have full control over itself. Basically a client-side actor, pretty much. So, but it'll also run on the server-side actor as well. So, yeah. And there's lots of good stuff here, like how to handle loops, things like that, case statements, go to, bunch of operators, and yeah. So, not Pandora. Alright. So there we go. There's our HT Inventory Manager class. Lots of stuff there, but boils down really simple. And it should get some sense out of it, especially if you, alongside, while you're reading or making, if you're actually going through and doing as I did, copy paste, stripping stuff, getting it to work. If you read along Inventory Manager, I think it's always a good idea to read a base class, even if you're not too solid on the Unreal Script language yet. You'll still have an idea of what things do what. So, alright, now our next class, or with this Inventory Manager class, we can now assign it to our pawn. You go to HT pawn, and in the big default properties block you'll see that it has a class, Inventory Manager class. Just go ahead and change that class to HT Inventory Manager now, and we'll start using that class. We'll start being able to add in our own inventory, which means we'll start adding in our own weapon code based off UDK weapon instead of UT weapon. So we can get some good stuff in there. Started soon. Now, alright, so now that we have our inventory manager, we can now do base HT inventory item, which I just subclassed and left it blank because I don't have any inventory items yet. But so that's 2 classes done. And now we're on our 3rd final class before we actually start getting into weapons code and getting our own custom stuff in game and running. We're going to need a base HT weapon class, and this HT weapon class there's some UDK weapon, and I added a few things in my weapon class that you don't necessarily need. Let's take a look at it, because I was doing a lot of debugging with HT weapon to make sure it would work. Now, the first thing I did was I created, I kind of took this from UT weapon, but I took their variable player view offset. It's a vector that basically offsets player view for first-person models. Turns out to be really, really helpful. Makes things a lot easier to adjust a first-person mesh. Now, this var first person, basically this categorizes this variable into the first person group of variables in HT weapon. We'll get into that later when we start doing actors that we place in the editor. I also created this function here called print screen debug. Now there are a lot of functions already exist that just print right to the screen or right to the log, but I thought this would just be a little nice convenient function to have in here. And what this does is that basically it has a local variable player controller PC, and that's just a player controller, and we store the player controller of, well, let's read this inside out. First, what we're doing here is we're grabbing the owner of this weapon and we're typecasting that to a pawn. Now, in part 3 we went over typecasting a little bit, and what this does is just allows us to manipulate owner as if it was a pawn, because right now owner is stored as an actor in all actor classes. Now, because it's stored as because it's an actual pawn, or in our case an HT pawn, by typecasting it to a pawn, you now have access to its controller variable. And its controller variable, because it's an HT pawn, it's a player's pawn, is a player controller. And this player controller specifically is an HT player controller, but that's not important because all we need to access is the base player controller functionality. And then we store this in our local variable that we just made. Now this line here checks to see if something was stored in player controller, because if any of these type conversions fail, then PC will have none or nothing in it. It won't be assigned anything, which means that our weapon is not owned by a player, or our weapon is either not owned by a pawn, or the pawn does not have a player controller. Either case, we have nobody to print to, so we should just not do anything. So we should check to see if there's something in it. And now, if there is something in it, we can use the player controller function client message, which basically prints a message to the client screen. And what I've done here is just add HT weapon colon. That way, everything I see on the screen that uses this function will have HT weapon printed on it. That way, I know that this debug code is coming from HT weapon. And it's a string. And you'll see that there's a $sign here plus the debug text. Now the $sign here, the $sign in Unreal script is what we call a string concatenation operator. I'm sure that's how you exactly say it, but what it does is basically you would usually think of it like this. You would have this string and then you would add debug text. But the $sign specifically adds 2 strings together. So what it's doing is whatever string you pass into debug, it's going to add it to the end of this HT weapon part, and then it will then print that to the client, and the client is whoever owns this weapon. So it's a nice little function to have your weapon print stuff. Now, what I've done here is I've created, well, I didn't really create, I've subclassed or overrid some states here, and these are common states found in every weapon, and this goes back to weapon code, like straight up engine weapon code. And on Codex, if you go to the bottom, you'll see it has a list of states here. And these are states that every weapon has, regardless of if you drive from UT weapon or not. If you're using the engine weapon class, it will have these states. So what I've done is I wanted to print out messages to my screen of when these weapon states are being triggered, because during the making of my weapon, it seemed like some of my states weren't being called, so I had to go back and make sure that they were being called, and they were. So you don't even have to have this code really, but you do have to have this block here, weapon equipping, this state here, because the base UT weapon or the UT weapon code, it has lots of logic of you picking up a weapon, equipping it, playing the right animations and things like that, which we have nothing near of, but in that logic, it handles attaching the weapon to the pawn so that you can actually see it. Now that function is the attach weapon to function, and that class, or that function, goes all the way back to the weapon class. And if you go back to the weapon class, you'll see that it doesn't do anything. It's just a stub. So, and it tells you it should be subclassed. Now if you look in game weapon, you'll see that it's not subclassed there. If you look in the UDK weapon, it's not there either. So the next place is a UT weapon. And if we go to attach weapon 2, you'll see that there's a function here that does some crazy stuff, but what all it does is basically creates a mesh and attaches it to the pawn, or it doesn't create a mesh, it just attaches the weapon to mesh to the pawn so that you can see it. It also does lots of arm mesh stuff, but because we don't have arm meshes and stuff set up yet, what I've done is I just took out all the arm mesh stuff and all the get hand stuff, because we don't even have code to say if you're left-handed or right-handed yet. So I just took out all this extra code and I'd only put in just enough for it to work. And you can see that function right here. We put the attach weapon 2 in the weapon equipping. That way, as you equip it, it attaches. But later, we're going to want to do some other logic that puts down a weapon and detaches and attaches and stuff. Because right now, this class doesn't detach itself, which means if you have more than one weapon, you'll see both weapons on your screen at the same time, and that's not good. But the attach weapon 2, this is just standard parameters for this function, but I'm not using either here, just like the U2 weapon doesn't use either as well. But it's basically just a straight rip off of the U2 weapon, except with a lot of the arm overlay stuff, and the third person stuff isn't implemented yet either, because we have to create a weapon attachment class that handles third person weapon models and stuff like that, but we'll get into that far later. As I said, it's easier to start with the no functionality and build up than it is to start with a bunch of broken functionality and tear down and then rebuild later on. Well, at least for me it is. So what this does is it checks to see if our pawn is an HT pawn, and if it is, it prints attaching weapon to the screen, because I want to see it, that print there, just so I know that this function is being ran. Because when I was coding this, I didn't know that I was supposed to call this function myself in a state or in anywhere. So I thought this was being called automatically somewhere, but this print screen debug showed me that no, it's not being called, because I never saw this. So I put this on weapon equipping, and suddenly my code starts working. So that's why we have functions like print screen debug. And you can also use the log preprocessor or whatever directive to print things to the log. But I was doing that for a while, but I got tired of running my game, giving me my weapon, closing the game, checking my log files, going back. Nah, I like it when it just pops up on the screen going, hey, this is what it's doing. And eventually we can code this so that it'll only do this if you have a debug variable set and cool stuff like that, but one thing at a time. Now with this block here, is it taken from a UT weapon? All it does is checks to see if we're in first person view right now, and if we are, it attaches our mesh to, what is it doing? It's basically, okay, it's attaching our mesh component to this class, which is owned by our actor, which means it's basically telling the engine to go, hey, there's a mesh here that needs to be drawn, so draw it, kind of, because there are components in the engine like mesh and other various components that they have their own logic that tells the engine what to do with it if it's installed as a component. We'll get into that a lot later, but yeah. Then we also have ensure weapon overlay component last. Honestly, I don't know what that does yet, so when I know what that is, I'll get back to you on that. Now, set hidden false. That just tells the mesh to not be hidden, because there are some other cases where it will be hidden, such as if it's not first person. Now, this here sets the light environment, so it does some lighting stuff. And we had to create this variable in our HT-Pawn class, because the UT-Pawn referenced it, and I like the light. I like to have a light environment variables, so we included that in our HT-Pawn, as I said in part 3. But this just makes that code work. Having that variable in there makes a lot of other code work, such as this code here. And then I just print another thing to the screen that says first person weapon attached, so I know that we are in first person and it did attach it. Now, if we're not in first person, it makes the weapon invisible, it makes it hidden, and it also sets our light environment anyway, so that if we do ever swap out of third person, our light environment will automatically be set up. And yeah. But it doesn't attach it because there's no reason to, because we're not going to see it. But we'll get into that later. And last function, there's only just these states, debug function, and the attach event, and the set position function. This event is called every time the weapon position needs to be updated, which is pretty much like every frame. And what this does is just updates the weapon so that if you rotate, like if you aim somewhere else, your first person model rotates as well, and it follows you, and it's put in the right place so that you can see it, so it's kind of always there. And what it does is, because this is for our first person mesh, this whole weapon code is only for our first person and firing stuff. The third person model is going to be handled in a weapon attachment, but we'll get into that later, as I said earlier. So what we have here is just a bunch of local variables we're going to use, and we return instantly if we're not in first person, because there's no reason to set the position of our first person model if we're not in first person. And if we are in first person, it just sets hidden to false. That way if we start out hidden and we switch to first person, it will unhide. Now, but this class here, what this does, all this does is it gets the viewport size of the screen, so that we can check if our viewport is widescreen. We don't actually, or in this code here, I don't actually do anything with the is widescreen variable yet, but in UT weapon it allowed for you to offset the rotation of the weapon, because in widescreen you have a little bit bigger of a you have a wider screen, so the weapon rotation kind of looks a little weird if you keep it on the standard 4:3 aspect ratio. So that's just a nice way of visually tweaking it based on widescreen or not. And This here just sets the mesh to its defaults, and is very important because this way the rest of these offset calculations are based off the default instead of the last position, which makes things easier. Now, view offset equal player view offset. Player view offset is a variable we created up here that allows us to basically offset the position of our first person mesh. That way you can adjust the position in code instead of going back and re-exporting a model or reconfiguring the origin of a model until it matches perfectly. We can just change the player view offset. And now what this here does is I'm not sure why holder.controller would equal none, but it works, so I don't question it. And this here, there's a bunch of, if you're watching a demo, it basically does spectator logic. I honestly have never tested this because we have a long way to go before we get into spectators and demo recording. But if we're not a demo recorder, we then have this here. And what this is that the draw offset is basically the view offset, and it shifts by it basically rotates it by our weapon holder's rotation. That way, wherever we're facing, the weapon matches that rotation. And we add a vector, a vertical vector, or basically an up vector, with the distance of our pawn's eye height. That way, because right now our position is pretty much relatively zero, which means wherever our pawn is at, it's basically at the feet of our pawn. If we add a vector that only has a unit vector in the up direction, and we multiply that by our get eye height, that'll create an upward vector of the distance from the ground to our eye height. And then we can add that to our offset so that instead of being on our feet, it'll be at our eye height so that it will match our camera and we can see it. And so that basically adjusts it to our eye, and this rotates it. And I just added this here to make sure that we are not a demo rec spectator, and just to make sure that this was being called. Because for a while, I had my weapon not facing the wrong way when I exported, and I could not see my weapon in game. And I could not figure out why I could not see it. So I had debug code everywhere trying to figure out what wasn't being ran. And it was all being ran, so it took me a while to figure out my weapon was just oriented the wrong way. And it should have been a really easy issue to spot, but there were some other issues that I was basically researching into, and I came across some wrong information, and long story short, it's better to test things yourself. Alright, now, if our holder is not, dot controller is not none, then it basically offsets our eye height by, in fact, I never actually see this. Try it. Yeah, this code never actually printed, so our holder.controller does have something in it, which makes sense. Which I guess there wouldn't be a controller if you're a spectator because it's demo recording and there's no controllers, you're already just watching pre-planned movement. So this is the code that's actually being ran here, which is very similar to this. Like, all we do is we do the same thing. We get the eye height, and because we're only manipulating the z part of this vector, we don't need to multiply it by a vector of a unit vector of an upward 1 unit vector length. Sorry I'm rambling, but just bear with me. But yeah, so we can just set the z directly to the eye height, And if we have an HT player controller, this was taken from UT Weapon. All this said UT player controller. All I did was switch out UT player controller with HT player controller. What this does is it offsets our drawing of the mesh by a shake offset variable we have in HT player controller. So we can, what this allows us to do is we can shake the first person mesh a little bit if we wanted to, and it then rotates it by the controller's rotation, basically wherever we're aiming. And then it rotates the view offset apparently as well. So what this does is it basically sets the pivot point for our first person mesh, while this takes our pivot point and then offsets it again by our view offset, which we assign player view offset along with the rotation again. It's math. It's math. So, and then we finally take our final location, and because all this is relative to our pawn, we have to put it, I guess you can say, convert it into world space, but it's not really exactly what it's doing, but it's pretty close. So we take the location, which gives it an idea of, like, shifts it from 0, 0, 0 to our holder's location. Our holder is our pawn, so it matches up with our person that we're moving around by our player controller, and then it offsets it by the offset we calculated, which is the eye height and all that stuff, rotation. And yeah, all this rotation just affects the pivot point, I guess, we're drawing, like the actual place. It just translates it, and then it sets the location. Set location is just a function that every actor has. It just sets the location of the actor to this final location. And set base is pretty much like, it's kind of like what the actor is currently on, and that just means our first person mesh is on our holder. So, and new rotation, basically, if we have a controller for a holder, or if we don't have a controller for a holder, it will just get our holder actor's rotation, whatever it is. If we do have a controller, it gets our controller rotation. That way it gets the rotation that we're aiming at. These two shouldn't be too different, but in a multiplayer game, this always isn't exact because it's not replicated like perfectly. I mean, you have lag and stuff on the internet that prevents the base rotation from matching the controller rotation of a client, which is why we have some demo logic up here that sorts some of that stuff out. Now, there's lots of UT weapon code that allows the weapon to kind of lag behind as you rotate. If you pick up any gun in Unreal, like the rocket launcher or whatever, and you rotate, like you spin around, you'll see that the weapon kind of shifts and rotates slightly to a little bit to the left and a little bit to the right, depending on which way you move, or up and down, pitches a little bit. And that is just some fancy visual rotation niceness that Epic has created. But there's some of that we haven't mentioned, like lag rot. I don't have those functions implemented yet, so this code would be broken if I did add that. But I do like that feature, so I'm just going to comment it out. And this just sets final rotation, our variable we created very long ago, to our new rotation. Now we could just straight up use new rotation because we're not manipulating this, because we're not doing any of this. But I figured might as well just keep it here. That way it fits in nicely with this common code, and if I wanted to go back and add that, we could. Now, I didn't include any variables for widescreen rotation offset, which is why I commented this out. But in the future, we can go back to this and we can add an offset for widescreen monitors, because we do calculate B as widescreen up here based on the viewport's aspect ratio, which is just basically width divided by height. So that allows us to do widescreen offsets, but we'll get to that later when everything's actually working first. Then we have our default properties block. This is taken right out of UT weapon, and I got rid of everything that the base weapon class has, but UT weapon doesn't, and which ends up into being a lot of a smaller default property block compared to other stuff. So it's just basic default stuff, like it just makes the weapon fire instantly, and the weapon has a 1 second interval between fire rates, has no spread, and does no damage, there's no momentum. There's a generic, generic settings, and meshes aren't even assigned here. It's just generic properties that every weapon has, and it assigns a first-person mesh to our mesh, and it has a pickup mesh because our base weapon class had some pickup mesh code. But other than that, that's all there is to it. We will be eventually changing message class and drop pickup class to our own classes, but all in good time. So there's no need to create those classes yet. Alright, so that's a lot of talking there, but that should explain what I did here, and it should make some more sense when you start reading through it along with the explanation in this video. Hopefully I haven't rambled too much, and you should have an idea of what's going on. And I won't be doing a line by line for this either unless enough people request it, even though I kind of just did. But these classes will be in the written version of this part. They'll just be pasted in there for you to use. And yeah, then we'll, after this part, check out my making an M16 in Unreal. And that goes to modeling a very badly modeled M16 just for a programmer art asset, just so we can test system code. And it goes through making the logic for our M16, getting it to have muzzle flashes and shooting specific sets of specific ammo, things like that. And then eventually that tutorial will be carried out and we'll go through the full creation of the M16, which means going back and getting a high quality model, rigging it fully, having sockets so we can add scopes and stuff to it, doing iron sight logic. It's something I want to be doing for the hunt and for another project of mine, things like that. So hopefully I'll try to get that up as fast as I can, and I'll see you then.